please, so that I can get everything together, okay? So we are going into quadratic functions. Does anybody remember from algebra what a quadratic function is?
It goes through all 4 sections of the graph.
Not necessarily, but good guess, Drew. It might, but it doesn't have to. A quadratic function is exactly what you see on the front there. It's that blue shape. It is the parabola, as we call it. Okay, so we're going to be learning about a lot of vocab today, and then we are going to also practice with the vocab and learn about different forms of quadratic equations or functions and figure out what information we get from each of them. So, here we go. Here are some vocab words. If you turn the page. So, a quadratic function, like I said, quadratic function is a function where the exponent is 2. That means it's the largest exponent. In other words, when you only have a quadratic relationship, a quadratic function, that's the only exponent you're technically going to have because the other ones are imaginary. So here I have this example for you. Y is equal to 2x squared plus 4x minus 5. Okay, I have that right there. That is a quadratic function because the highest exponent is 2. You have that x squared. But it is important that you understand that the squared, the 2, is on the variable. If you have that exponent of 2 anywhere else, it would not be considered quadratic. But notice I still have that other little x in there. If I wanted to, the exponent that is on that x, remember we have those imaginary ones. But we do not usually write that, so we're going to leave that off. But just so you know, there are other exponents there. The shape of a quadratic function will always be a parabola. So it'll be a U that opens up, or it'll be a U that opens down. The axis of symmetry is the line that divides the parabola into 2 congruent parts. Okay, 2 congruent parts. The thing about parabolas, just like absolute value, a lot of what we know about absolute value stuff that we learned in Unit 1B is going to also follow to be true for this quadratic functions. And they're symmetrical. So with the absolute value, you would have the V. If you could cut or fold the piece of paper on that vertex of the V, everything would match up perfectly on the left side and the right side. That is the case also with parabolas. They are symmetrical, so the left will match up perfectly with the stuff on the right. The vertex is going to be your lowest or your highest point of the U. It's going to be the turning point, where it goes from decreasing to increasing or increasing to decreasing. The roots are the same as the zeros or the solutions. That's when the equation is equal to 0. So what values of x would make that whole thing equal to 0? X-intercept and y-intercept you should be comfortable with by this point. And then the maximum is going to be the highest point and minimum is going to be the lowest point. So if we take a look at the bottom of that first page, this is the parent function. That's the one that everything stems off of. And then remember for absolute value, we talked about all of those shifts. Same idea here. Instead of having y is equal to the absolute value of x, and now we have y is equal to x squared. That is the bare minimum quadratic function that you can possibly have. We can do horizontal shifts to that. We can do vertical shifts to that. We can make it narrower. We can make it wider. We can make it open down. And we're going to learn how to do that today. Okay? But for this first part, it says that we need to label the axis of symmetry, the vertex, the x and y intercept, and then the minimum or maximum point. The thing about this parent function is a lot of those things are all at the origin. So I'm going to go ahead and I'm going to highlight the axis of symmetry. Why is that the axis of symmetry? Perfect, Jordan. If I could take my iPad and fold it, I can't, but you could take your paper. If you folded it right there on that y-axis, everything would match up on the left side that's on the right side. Okay, from there then, we have the vertex. That is the turning point. So for this particular example, it is at the very bottom, which is at the origin, that 0, 0 point. That vertex also turns out to be the x-intercept, because it's where the parabola crosses the x-axis or touches the x-axis. It also turns out to be the y-intercept. And it also turns out to be the minimum point. So that origin is all 4 of those things. That's not what we always have to have, but in this example, that is what we have. Okay? Any questions about any of those vocab words? Okay, then let's talk about the different forms. There are 3 different forms for quadratic functions, and each one gives us important information that we are going to talk about today, and by the end of today, you have to be able to identify what form the equation is in and what key points you're going to be able to find from that form. So the first one is vertex, that's given to us. We have y is equal to a, and then in parentheses we have x minus h. Then we have a squared outside the parentheses and plus k. So this is the one that is very useful for transformations, just like we did with absolute value. Okay? This will give us our horizontal shift. This will give us our vertical shift. This will give us all of that information. But we'll learn that a little bit later. For the first thing we're going to get from it, and the most important thing, if it's called vertex form, it makes sense that we are going to be given the vertex, that low point or that high point. Where do you think the vertex is going to be? And think back to absolute value. Where do you think the vertex is going to be? Almost identical. That was if it's the parent function, but once we add like a horizontal shift or a vertical shift, it's no longer going to be at that origin. Remember how with absolute value we looked at that h and the k? Those gave us the horizontal and vertical shifts for absolute value. It's the same thing here. So h is the opposite of what we think it is. So our vertex is going to be at the opposite of what's inside the parentheses, and then true to whatever k is. That's going to be our vertex. And remember, that's either going to be the very lowest point if it's a U opening up, or it's going to be the very highest point if it's a U opening down, or an N. We are also going to be given the axis of symmetry using this form. The axis of symmetry, remember, is that imaginary line that we would fold the paper on to see the symmetrical 2 sides. This is going to be x is equal to whatever your h value is. So whatever that h coordinate is from the vertex, that's going to be your axis of symmetry. Okay, that's the first form. The second form is the standard form. That's one you probably were most familiar with back in algebra, but that was so freshman year. So who remembers that stuff? So y equals ax squared plus bx plus c, where you will plug different numbers in, or you will be given different numbers for a, b, and c. Okay? All those will be different numbers, but you will still have the x squared. You might have the x, you might not. Okay? But that's the standard form. From there, the one thing that you get, so standard form is probably my least favorite, least useful, is the y-intercept. And the y-intercept, remember, is where the graph crosses the y-axis. So this will be at the point 0, C. Whatever C is in your equation, that's going to be your y-intercept. Last one, factored form. Factored form is y equals a, and then in parentheses x minus p, and then another set of parentheses x minus q. In factored form, we can identify very easily the x-intercepts, which, remember, are opposites of the y-intercept. It's where the graph, in this case the parabola, would cross the x-axis. Now, there aren't always two, but if there are, they would be given at the points P0 and Q0. So, opposite of what's inside each of the parentheses would then be your x-intercepts. You can also identify with this form, though, the axis of symmetry. And to do that, since you have the x-intercepts, which have to be equal distance from that axis of symmetry, you actually take the two of them and average them. You find the halfway point. That's just averaging the information. So you would take both of your x-intercepts, add them together, and divide by 2. And that would give you your axis of symmetry. Okay? Those are the three forms. Now let's talk about the shape. The shape comes from your A. It comes from your A component from each equation. And you will notice, if I look at each one of these, I have A in vertex. It's outside in front of the parentheses. I have A in standard form. It's in front of the x squared. And I have A in factored form outside the first parentheses also. So in any of the forms, you can identify A. If A is positive, what happens? There you go. Same thing as absolute value. And if A is negative, it's like an N shape. So you either have your U shape or you have your N shape. But it also helped us to identify if it was going to be a narrower V or a wider V for absolute value, and it's going to do the same thing here as well. If the absolute value of A is greater than 1, so 2, 3, 4, negative 8, negative 10, that's going to be narrower. If the absolute value of A, I can't just say it's going to be less than 1, because absolute value can never be negative. So it's going to be somewhere in between 0 and 1, 1/3, 1/4, 1/2, something like that. It's going to be a wider parabola. Okay, we're going to come back to how to plot the points after some practice with these forms, okay? So let's scroll down to number 1. It says, for each quadratic function, tell which form the function is in and give the important points that you can find from that form. So the first thing we have to do is look at this number 1, y equals x minus 3 and x plus 1 in 2 separate parentheses. What form does this look closest to? Does this look... Okay, there you go. Didn't even have to scroll up. I would absolutely agree that looked like factored form. From factored form, what are the key points that we can identify? Right? Drew, it's not a competition. Stop. So, who can raise their hand and tell me what one of the x-intercepts would be? One of the x-intercepts. Landon? Careful. Look at it in factored form. We had x minus p, and we said that the x-intercept for that would be p0. So it's the opposite. There you go. So anytime it's in parentheses, like the absolute value, it's the opposite of it. So that would be 3, 0. And then the other one, Drew? I need more.
0.
Thank you. What else can we find from factored form?
Axis of symmetry.
Okay, so let's take a look at that. All we did to find the axis of symmetry was, remember, average your two x-intercepts. So we've already identified the x-intercepts to be 3 and -1. So I'm going to add the two together and divide by 2, just like if you average anything. So 3 plus -1 is 2, divided by 2 would be 1. And that's x equals. So when x equals 1, that's going to be the imaginary line that you can fold on the graph, and your left side would match perfectly up with your right side. And for all three forms,